Welcome to another AI pattern recognition deep dive.
Your shortcut to understanding the complex tech shaping our future. Today, we're tackling something really crucial, human-in-the-loop systems, or HITL, as you'll hear it called.
That's right. We've been digging into a pretty dense monograph covering the whole landscape, the architecture, the ethics, the resilient side of things, basically, how you responsibly build and use AI today.
And our mission, really, for you listening, is to break down this idea that AI can just run totally on its own, that vision of full autonomy.
It's often idealized, let's put it that way. In many real-world situations, especially high-stakes ones, it's not just inefficient, it's fundamentally unreliable. It simply doesn't work as advertised sometimes.
So we're going to map out where that human judgment is absolutely essential,
No,
non-negotiable, really, and how organizations are actually building that human element into the system design.
Exactly. It's not an afterthought. It's baked in from the start.
Okay, let's unpack this then, because we're not just talking about, a simple override switch.
Right.
This sounds much deeper, like embedding people right into the core architecture.
Yeah.
It feels like a major shift from just chasing pure automation.
That's precisely it. HITL is fundamentally a strategic move, a different paradigm. It's about collaboration, deliberately integrating human input, human expertise across the entire life cycle of the AI system.
The entire life cycle. So from
Yeah.
training all the way to.
All the way. Training, evaluation, ongoing operations. It's really an acknowledgement of limits.
Sure.
Machines are incredible at scale, at computation, spotting patterns quickly, no question.
Right.
But they fundamentally lack certain things humans bring. Real judgment, the kind that isn't just following rules. Deep contextual understanding, knowing why something matters, not just that it correlates. And critically, ethical reasoning.
Especially when the stakes are high.
Absolutely. So HITL systems are designed to leverage the power of the machine, but also to mitigate its inherent brittleness, its lack of common sense, if you like.
Okay, so the machine handles the grunt work, the scale. Let's get into the structure then. The plumbing of this feedback loop. The source material lays out 3 mandatory stages. Stages where human interaction is basically required for the AI to work reliably. Walk us through that. How does an AI go from just an idea to something safe and operational?
Okay, stage 1, it's foundational, data annotation. Or you could call it input generation. Think about supervised learning. The AI learns from labeled examples.
Right, you have to show it what's what.
Exactly. And the quality of the final AI, it's directly tied, directly to the quality of those initial labels. This is absolutely vital when the input data isn't clear-cut, when it's subjective or ambiguous or needs real domain expertise.
Like what? Give us an example.
Okay, imagine trying to train an AI to identify very specific, rare geological formations from satellite images. Not just rock, but this specific type of metamorphic outcrop. Or, say, spotting subtle signs of sophisticated financial fraud, the kind only a really experienced analyst would catch.
Okay, yeah. Stuff that requires judgment?
Precisely. You need human annotators, ideally, subject matter experts, to provide those high-quality, nuanced labels right at the beginning. This whole phase is about aligning the model's basic understanding with what experts consider correct or high quality.
So the human is the quality gatekeeper from the very start.
Yeah.
Defining good before the AI even starts learning. And if you mess this up, maybe try to cut corners with cheap labeling.
You've compromised the entire system's reliability right out of the gate. Garbage in, garbage out, quite literally.
Okay, makes sense. So you've got your expertly labeled data. What's next? Where does the human step in during the actual training?
That brings us to stage 2, model training and tuning. And this isn't a passive stage where you just hit run and wait. This is where human machine learning teams are actively involved. They're monitoring the model's progress, often in near real time.
How? What are they looking for?
They're analyzing intermediate outputs, looking at how the model is actually learning step by step. They're specifically hunting for points where it's failing or getting confused. This constant feedback loop lets the experts course correct.
Course correct against what exactly?
Well, crucially, they make sure the model can generalize, that it doesn't just memorize the training data, and they ensure it can handle those tricky, infrequent situations, the edge cases.
Edge cases, the stuff that doesn't quite fit the standard pattern.
Exactly. They always exist in the real world, right? Outside the nice, clean boundaries of the training data set. This continuous tuning also helps prevent major problems like overfitting.
Right, I've heard that term, overfitting is.
It's when the model gets too good at the training data. It essentially memorizes the answers instead of learning the underlying patterns. So it looks great in testing on similar data, but then it falls apart completely when it sees new real-world variations. Human oversight during tuning helps prevent that.
Okay, so training is about guided refinement, keeping the model on track. But the real test comes when it's deployed, right, when it faces the messy reality. That leads to the third stage.
Exactly. Stage 3 is testing, evaluation, and correction. This is ongoing, operational review. Humans are rigorously assessing the AI's outputs in the real world, checking for quality, safety, ethical alignment, everything it's supposed to do.
And this isn't just about finding errors, it's about feeding the corrections back.
That's the critical part. It's the mechanism for continuous improvement. When the model makes a mistake, maybe its performance drifts because the world changes, or it encounters something totally unexpected. Subject matter experts have to step in.
Okay.
They diagnose the failure. Why did it misclassify this medical image? Why did it flag this transaction incorrectly? They correct the specific instance, but crucially, they feed that corrected example, that new piece of knowledge, back into the training data set.
So the model learns from its mistakes.
Precisely. It keeps the AI dynamic adaptable. It prevents the same failure from happening over and over. You're turning failure into learning. That's the loop. Annotate, train, correct, and repeat.
That structure makes a lot of sense. Annotation, training, correction.
Yeah.
But let's talk practicalities. If every single AI decision needed 3 expert humans checking it, well, that would be incredibly expensive, right? Impractical for most organizations.
Absolutely. The cost would be astronomical. And the source material acknowledges this. It outlines a necessary spectrum of human intervention. You have to be strategic because human expertise is a finite, costly resource.
Okay, so it's not all or nothing. What does this spectrum look like?
Well, the monograph lays out 3 main strategic levels. It depends on the required friction, how much human involvement is needed, and the value or risk associated with the decision. The first level, the highest friction one, is the classic human in the loop, HITL.
The one we've been mostly discussing.
Right. This is for processes where human judgment is absolutely non-negotiable. We're talking high complexity, irreversible consequences, or deep ethical considerations. Think, final approval for a major medical diagnosis suggested by an AI, or a legal tech system pre-screening critical liability documents. A human must actively review and sign off on high-impact outputs. It's high cost, high friction, but essential for accountability.
Okay, that's the deep end. What about scenarios where you need more speed and scale, where constant review isn't feasible?
That leads to the second level, human on the loop, HOTL. Here, the focus shifts towards speed and scalability. The AI is generally trusted to operate autonomously most of the time.
So the human is more of an overseer.
Exactly. They primarily monitor the overall system performance, its health. They only intervene reactively.
Reactively meaning when?
When the system itself flags something, maybe its confidence score for a particular decision drops below a set threshold. Or if a critical failure alert pops up, like a sudden drastic deviation from expected behavior.
Can you give an example of HOTL?
Think about large-scale content moderation on social media. An AI can probably handle 99% of the obvious stuff, spam, clear violations. The human moderators only step in for the really ambiguous cases, the ones flagged by the AI as uncertain, or those potentially violating complex, nuanced policies. It's about being ready to intervene, not reviewing every single piece of content.
Okay, so HITL is constant involvement, HOTL is reactive oversight. What's the third level?
The third and lightest touch is human in command, HIC. Here, the AI acts purely as an advisory tool. It provides predictions, analysis, suggestions.
But the human makes the final call.
Always. The human maintains ultimate decision authority. They use the AI's output simply as supplemental information to inform their own judgment. Think of a military commander using AI projections of battlefield risks, or a surgeon using an AI visualization tool during a complex operation. The AI assists, maybe highlights things, but the human is firmly in command, making the actual decision.
Got it. So HITL, HOTL, HIC. A spectrum of involvement depending on the need. Understanding that is key for actually implementing this stuff affordably.
Absolutely vital. It lets organizations balance reliability and safety with the practical costs of human oversight.
Okay, let's shift gears a bit. We've talked about the how, the architecture. Now let's dig into the why. The fundamental reasons why we even need all this human oversight. You mentioned AI brittleness earlier.
Yes. And what's fascinating here is just how inherently fragile purely autonomous AI can be. It sounds counterintuitive, maybe? AI is amazing at finding patterns, correlations, in vast data sets.
Yeah, that's his strength.
But it's fundamentally brittle when it encounters data that's significantly different from what it was trained on. Those edge cases we talked about. They can completely break an autonomous system. It lacks robustness outside its specific training zone.
The source material really hammers this point home. The real world is just messy, much messier than any clean training data set. Can you give us a concrete example of this brittleness causing a failure in a high-stakes situation?
Okay, let's stick with finance. It's a good example. Imagine a big investment bank using an AI, a document intelligence system, to process thousands of complex regulatory filings every day.
Okay. High volume, complex data.
Right. And in the development phase, in the sandbox with perfectly formatted test documents, the AI is amazing. Near 100% accuracy, looks fantastic.
But then it goes live.
Exactly, then it hits production. And suddenly it's dealing with real-world chaos. Scanned documents that are slightly crooked, maybe have coffee stains obscuring text, different regional formats for dates or currencies it wasn't explicitly trained on, like Japanese yen versus US dollars formatting, or highly specific industry jargon that just wasn't in the original training beta.
And the accuracy plummets.
It can collapse. Suddenly that 100% accurate model is only hitting 60%. Why? Because it wasn't trained for that inherent noise and ambiguity of the real world. It's brittle.
So just throwing more data at it isn't always the answer. It's about having the human expert who actually understands that messy reality, the context.
That's the core insight. Full automation often fails in dynamic, complex environments because it just can't interpret context it hasn't explicitly seen before. HITL is about transforming the AI from a purely deterministic, brittle tool into something more resilient. A socio-technical system.
Socio-technical, meaning human and machine working together.
Precisely. The human provides that crucial non-deterministic input, the contextual understanding, the judgment, the adaptability. That's what provides the resilience. Without that human element, the system is always potentially one weird input away from a major failure.
And this ties directly into needing skills that aren't algorithmic, right? We're not just talking about checking the map. We're talking about things like moral judgment.
Exactly. In really high-stakes fields, healthcare, autonomous driving, legal strategy, defense, you need more than pattern matching. You need moral deliberation. You need understanding of social norms, cultural context, nuance.
Things you can't just program into an algorithm.
You really can't. No algorithm truly understands why something is fair or unfair, or the potential downstream social consequences of a decision. HITL is the mechanism for strategically inserting that necessary ethical and contextual friction into the system. It helps ensure the outputs stay aligned with human values, not just statistical optimization.
Okay, this makes the transition really clear. We understand why HITL is needed, this brittleness, the need for context and ethics. Now let's look at where it's becoming absolutely mandatory. The source material dives into some critical sectors. Let's start with health, genetics, biology, very personal, very high stakes.
Right. In medicine, AI is already making huge strides, especially in analyzing high-volume, complex data. Think radiology, using things like convolutional neural networks, CNNs.
Those are the image recognition AIs.
Exactly. They're incredibly good at spotting subtle patterns in medical scans, like classifying tumors or identifying anomalies that might be missed by the human eye. AI can also analyze, say, speech patterns for early signs of cognitive decline or sift through genetic data for disease markers.
But the consequences of an error, they're potentially devastating. Life and death, literally. So the human role here isn't just helpful, it's essential. Mandatory diagnostic oversight.
Absolutely mandatory, no question. The AI can provide powerful initial analysis, suggest diagnoses, flag things for attention, act as an incredibly sophisticated filter. But the human clinician, the doctor, must be the one to validate, interpret, and refine those findings.
Why? What does the human add that the AI misses?
Context. The doctor understands the whole patient, their history, their lifestyle, their specific circumstances. The human oversight is critical for safety, for ensuring accuracy across diverse populations, and simply for meeting legal and ethical standards of care.
And the sources really emphasize the ethical angle here, too. The human as the gatekeeper against bias creeping into the models.
Yes, and this is a huge problem in healthcare AI. Medical data itself is often biased, reflecting historical inequities in access and treatment. If you train an AI on that data without correction,
It learns the biases.
it learns them, and worse, it can amplify them. It can statistically enshrine those historical biases. Imagine an AI trained predominantly on data from one demographic group. It might perform poorly or even dangerously when applied to other groups.
How might that play out specifically?
Well, a classic example is using historical healthcare spending as a proxy for future health needs. Some studies showed AIs were predicting lower needs for certain minority populations because, historically, less money had been spent on their care, reflecting access issues, not actual lower need.
Wow. So the AI learns that less spending equals less need, and then recommends less care, perpetuating the cycle.
Exactly. It's optimizing based on flawed historical data. The human practitioner in the loop has to apply rigorous ethical judgment here. They have to challenge the AI's statistical conclusions and ensure the system promotes equity, not just optimizes based on biased inputs. They prevent the AI from amplifying societal imbalances.
That's a critical function. And looking forward, the monograph talks about HITL moving to the edge in healthcare, continuous monitoring.
Yeah, this is about the next wave of wearable and implantable tech. Flexible sensors, maybe smart tattoos, microneedle patches, devices constantly tracking vitals, heart rate variability, blood glucose, inflammatory markers, you name it, 24/7 monitoring.
Which generates a ton of data.
A massive continuous stream of data. And you can't realistically send all that to the cloud for processing in real time. The latency would be too high for critical alerts.
So you need processing right there, on the device or nearby. Edge computing.
Precisely. This requires specialized hardware-powerful, low-power edge AI processors, things like the NVIDIA Jetson Thor or even neuromorphic chips designed to mimic brain processes. They can handle that huge data volume locally with very low latency.
And how does that change the human role?
It pushes the oversight closer to the individual. Instead of a doctor reviewing periodic reports, the human in the loop might be the patient themselves or a caregiver responding to real-time alerts or interpretations from their own device, validating its readings, providing context. The loop becomes much tighter, much more immediate.
Fascinating. Okay, let's shift scale completely now. From individual biology to global geopolitics, history, politics, conflict, escalation, AI is being used here too, trying to spot patterns.
Absolutely. Governments and organizations are training AI on vast data sets, economic indicators, social media sentiment analysis, migration flows, political polarization metrics, historical conflict data like the SAGE database, trying to identify the subtle correlations that might precede geopolitical instability or conflict.
Trying to predict crises before they happen.
Essentially, yes. Identifying potential flashpoints, forecasting structural risks in states or regions.
But this is where that gap between pattern recognition and real-world strategy becomes incredibly stark, isn't it? The source material uses a really potent historical example here.
It does, and it highlights the limits perfectly. AI is undeniably good at spotting complex historical patterns. For instance, an AI could analyze the factors leading up to the rise of Nazism in Weimar Germany.
What would see?
It would flag the correlations. A severe economic shock, the Great Depression, followed by prolonged high unemployment, coinciding with rapidly increasing political polarization and the collapse of the political center. The AI identifies that sequence, that pattern of structural failure.
Okay, it sees the correlation.
Yeah.
But it doesn't understand the meaning.
Exactly. The algorithm detects the pattern, but it can't interpret the velocity of the crisis, the specific political dynamics, or the profound moral implications. That requires human expertise. A geopolitical analyst, a historian, a diplomat, they interpret the pattern, assess the real risk, and determine the appropriate ethical, non-algorithmic response.
Because the AI can flag high unemployment and polarization, but it can't judge if that's just political turmoil or the prelude to something catastrophic.
Precisely. It can't assign the moral weight. And imagine if an automated prediction triggered some intervention that backfired, making things worse. Who's accountable? That accountability vacuum is why autonomous decision-making in high-stakes geopolitics is unacceptable. Human experts must vet these predictions, provide the strategic context, and make the final ethical judgment call.
That accountability piece seems crucial across the board, which brings us neatly to the economic domain. Inequality, resource distribution, financial systems. AI is everywhere here, but human oversight is needed to prevent systemic bias.
Deeply integrated. AI runs risk assessment models, fraud detection systems, automated transaction approvals. Humans typically review the exceptions, the flagged cases, but the huge risk, again, is that the AI learns biases from historical data.
Even if sensitive attributes like race or gender are removed.
Yes, because it learns from proxies, variables that strongly correlate with those sensitive attributes. We talked about the healthcare example using spending as a proxy for need. In finance, it could be zip codes.
Also,
Well, imagine a loan application model. It might learn that certain zip codes have historically higher default rates. If those zip codes also happen to correlate strongly with minority populations due to historical segregation patterns.
the AI effectively redlines those areas even without explicitly using race data.
Exactly. It reinforces discriminatory practices because it's just optimizing for statistical risk based on biased historical patterns. The human in the loop is essential here to recognize this potential for systemic bias and intervene, to ensure that the pursuit of, say, profit maximization doesn't override fundamental principles of fairness and equity.
And this issue of bias connects to other areas too, like criminal justice concerns mentioned in the sources.
Yes, particularly things like facial recognition technology. Studies have shown some systems have drastically higher error rates for certain demographics, like dark-skinned women. Relying on such flawed systems without human oversight can perpetuate injustice. HITL mandates intervention, potentially halting deployment until the bias is addressed. It's about preventing the deployment of what amounts to race science patterns encoded in algorithms.
Okay, and then there's generative AI, GAI. That throws a whole new wrench into the works regarding ownership and truthfulness, doesn't it?
Oh, absolutely. GAI has exploded, making content creation accessible, but it simultaneously creates enormous ambiguity. Intellectual property, commercial rights, copyright, it's a minefield.
Well, if an AI generates an image based on millions of training images, who owns it?
Great question. The person who wrote the prompt. The company that owns the AI model.
Yeah.
The original artist whose work was used in training without explicit permission. It's incredibly complex, and that's before you even get to the risk of deepfakes and mass synthetic misinformation.
So what's the HITL solution here?
It requires continuous loop of human oversight. Human curators to evaluate the quality and originality of generated content. Legal experts to navigate the copyright and ownership issues. Moderators to identify and mitigate misinformation and harmful outputs. The mandate is clear. These powerful GAI systems need guardrails. Human judgment must ensure they align with legal standards and societal equity, not just optimize for generating convincing outputs.
All right, let's pivot to what feels like the philosophical core here. Accountability, liability, ethics. We've established HITL is needed for safety and reliability. But
Here's where it gets really interesting. When we put a human in the loop, who takes the blame when something goes wrong?
yeah, because things will go wrong eventually, right? Even with oversight. So who's responsible? The human, the algorithm, the company.
That's the million-dollar question, and it cuts to the heart of the problem with fully automated black box systems. Deep learning models especially can be incredibly opaque. Their reasoning is often impossible to fully trace, so when they cause harm...
There's no clear chain of responsibility, an accountability vacuum.
Exactly, and that's simply unacceptable in high-stakes domains.
So how does HITL address this? It's not just about preventing errors, it's about creating transparency, a legal utility.
That's a huge part of it. HITL fundamentally improves transparency and explainability, often called XAI. How? By creating a clear audit trail.
An audit trail, like a log of what happened.
A detailed log. It documents why a decision was made by the AI, why it might have been flagged as uncertain or risky, and crucially, if and why a human operator intervened, corrected, or overturned that decision.
Ah, so you can trace the decision-making process, including the human input.
Precisely. This institutionalizes a framework for shared liability. That detailed record, the interaction history between human and machine, becomes the key evidence. It helps determine if the fault lies with a flawed algorithm, maybe data bias, maybe a design error, or with the human operator, perhaps inadequate training, negligence, failure to follow protocol.
That completely reframes the human role. It's not just about having a person there. It's about ensuring they are competent and acting responsibly. A mandate for competence.
Exactly right. The trustworthiness of the whole system doesn't just depend on the human's presence, but on their competence. And regulations are increasingly reflecting this. They require that the human in the loop is properly trained, that they actually understand the AI's limitations and failure modes, and that they have the genuine authority and capability to intervene effectively.
So it raises the bar for operational design. You can't just stick anyone in front of the screen.
No, it promotes fairness and equity by ensuring the human isn't just a rubber stamp, but an effective ethical and technical check on the system's power.
Okay, but this leads us straight into a paradox, doesn't it? The source material calls it the human paradox, or sometimes the self-destruction paradox. We're relying on humans for judgment, context, ethics. But humans are flawed. We make mistakes, we have biases, we get tired.
It's the central tension, absolutely. If AI is partly designed to overcome human limitations like fatigue or statistical bias in processing vast data, why is the ultimate solution to rely back on the flawed human?
Yeah, it seems circular.
Well, HITL is fundamentally an architectural strategy designed around human imperfection, leveraging strengths while mitigating weaknesses. We use the human for the things they excel at: nuance, ethical judgment, contextual understanding, adapting to novelty. And we use the AI for what it excels at: scale, speed, detecting complex patterns in data, tireless consistency in repetitive tasks.
So they cover for each other's weaknesses.
In a way, yes. The human mitigates the AI's lack of common sense and ethical grounding. The AI mitigates the human's limitations in processing speed, scale, and susceptibility to certain biases or fatigue. It aims for anti-fragility, making the combined system stronger than either part alone.
But let me push back on that slightly. If the AI is smart enough, as we'll discuss later, to only route the hardest, most ambiguous, lowest confidence cases to the human, isn't that setting the human up for failure? Or at least extreme cognitive load and burnout? Are we just giving the humans the AI's worst garbage?
That is a critical design challenge. You've hit on a major risk. If you're not careful, the human operator becomes what some call a humbot, basically, a human forced to operate at machine speed, constantly dealing with the most difficult, often distressing or ambiguous edge cases.
Which sounds exhausting and demoralizing.
It absolutely is, and it degrades judgment quality over time. Effective HITL design must prevent this. The goal isn't to turn humans into faster, cheaper processors for the AI's difficult bits. It's about elevating the human role.
Elevating how?
By ensuring the system design pivots the human focus away from repetitive, low-level screening towards higher-value tasks. Strategic evaluation, ethical deliberation, setting boundaries for the AI, refining its goals, handling true novelty. It requires careful workflow design and ensuring the human tasks are meaningful and manageable.
Okay, so it's about redefining the human's purpose in the system, which suggests a shift in the workforce too. Less routine work, more oversight and judgment.
Definitely. We're seeing a significant pivot: repetitive data entry or simple classification, increasingly automated. But new roles are emerging, roles that depend on that human judgment interacting with AI.
Like what?
Things like output curators, people who take AI-generated content, text, images, code, and refine it for quality, style, brand alignment, ethical considerations. Or AI and process evaluator specialists who monitor how AI systems are performing not just technically, but against broader business goals and regulatory requirements. Also, new product prototypers experts using AI tools to rapidly generate and then validate new ideas or designs for real-world feasibility.
So the human becomes less of a data processor and more of an ethical gatekeeper, an arbiter of nuance.
That's a great way to put it. The ultimate arbiter of nuance and value. The AI handles the scale, freeing up the human cognitive capacity for the complex stuff only humans can do.
Which brings us to the final big piece: efficiency. We keep touching on the cost. Constant human review is expensive. So the future of HITL can't just be throwing more people at the problem. This leads to the idea of prescriptive AI.
Exactly. If we connect this to the bigger picture, the future of HITL isn't just humans overseeing machines, it's machines becoming incredibly efficient managers of human resources.
The machine managing the human. Tell me more.
Well, the long-term viability of HITL depends on making it cost-effective. That means using AI itself to optimize the human involvement, to minimize unnecessary reviews while maximizing the value and learning gained from the interventions that really matter. The AI becomes prescriptive. It tells the human precisely where their limited attention is most needed.
How does it do that? Sounds like that concept you mentioned earlier, active learning. How does that actually work in practice?
Active learning is really the engine driving this optimization. Instead of just randomly sampling data points for a human to label or review, the AI model actively tries to identify the instances where human input will be most valuable for improving its own performance.
Most valuable how? How does it know?
It often uses techniques called uncertainty sampling. Basically, the model identifies the predictions it's least confident about. The cases where it's effectively saying, I'm really not sure about this one. Is this tumor benign or malignant? Is this transaction fraudulent or legitimate?
So it flags its own uncertainty.
Precisely. By concentrating the limited human review effort on these hardest, most ambiguous, lowest confidence examples, the system gets the biggest bang for its buck from each human interaction. The model learns much faster, and you avoid wasting expensive human time reviewing easy cases the AI already handles well.
Okay, so active learning makes the human input much more targeted and efficient. Smarter labeling. But the source material also mentions something even more advanced, the system creating artificial experts.
Yes, this is a step beyond just routing uncertain cases. It's about the system learning to handle new types of uncertainty autonomously over time. Imagine the system encounters a cluster of data points that are completely novel and unknown class that the human experts haven't seen or defined before. Initially, a human expert would need to classify a few examples from this new cluster, but then a sophisticated hybrid HITL system can learn the patterns specific to that new class. It essentially generates a specialized mini-model, an artificial expert tuned just for recognizing that newly identified pattern. And then the system can start using this artificial expert to classify future instances of that specific edge case. It might even have mechanisms to automatically assess how competent this new artificial expert is. If it's deemed reliable enough, it can take over handling that particular type of difficult case, dramatically reducing the need for ongoing human intervention for that specific pattern. It's about automating the handling of generalized edge cases over time.
That's pretty sophisticated, automating the expertise itself. Now, when we talk about these complex interactions, especially with advanced AI like large language models that perform multi-step tasks, how do you structure the human input? Are there standard ways to pause the AI and get feedback?
Yes, for safety and control, especially with agentic AI that can take actions in the real world, you need formalized input mechanisms. The monograph highlights two key architectural design patterns.
Okay.
The first is approve or reject. This is a hard gate. The system performs a task up to a critical, potentially irreversible step think, executing a large financial transaction, submitting a legal filing, finalizing a medical treatment plan, and then it pauses. It explicitly requires a simple yes or no confirmation from a human before proceeding.
A safety check for high-stakes actions.
Exactly. It prevents the AI from autonomously taking actions with major consequences without explicit human sign-off.
Makes sense. What's the second pattern?
The second is get input. This is more collaborative. The system pauses during a multi-step task or conversation because it realizes it's missing crucial information or context needed to proceed accurately.
So it asks the human for help.
Yes. It might say something like, to complete this market analysis, I need the Q3 sales figures for the European region. Please provide this information. Or, I need clarification on the legal jurisdiction for this contract clause. It explicitly requests the specific domain expertise or contextual data it lacks, ensuring it doesn't just guess or hallucinate the information.
Okay. Approve reject for critical steps. Get input for missing context. That seems practical. But the most advanced level of this prescriptive HITL sounds almost sci-fi. Cognitive load monitoring. The AI monitoring the human.
It sounds futuristic, but it's a logical extension, especially given the emphasis on human competence. Remember, HITL relies on the human reviewer being capable and alert. If that competence is compromised by fatigue, distraction, stress, the entire safety premise breaks down.
So the AI watches the human for signs of being unfit for duty.
In a sense, yes. It's a meta-governance system. The AI monitors the human operator's interaction patterns, looking for deviations that suggest compromised judgment.
What's it actually monitoring? It sounds a bit invasive.
It typically monitors interaction dynamics passively. Things like the speed and consistency of their review decisions compared to their baseline. Are they suddenly much slower or much faster and potentially less careful? Are their mouse movements erratic? Is their typing speed dropping? Some systems might even incorporate non-invasive measures like camera-based eye tracking to check for signs of drowsiness or distraction.
Okay, so it learns a baseline for alert and competent for that specific user.
Right, and if it detects significant deviations, say review speed plummets, decision consistency drops, prolonged inactivity, it flags a potential risk that the human's judgment might be impaired.
And what does it do? What's the prescriptive action if it thinks the human is compromised?
It takes proactive steps to maintain system safety and decision quality. Depending on the system design and the criticality of the task, it might dynamically reassign the current task to another, presumably rested, human operator. It could trigger a mandatory break for the fatigued reviewer. Or, in very high-risk situations, it might invoke a safety fallback procedure or even temporarily pause that part of the system until reliable human oversight is restored.
Wow. So the AI ensures the human part of the loop remains reliable. That really closes the loop on managing the human resource effectively. The need for specialized hardware, like neuromorphic chips, makes sense here too, for processing all that subtle human interaction data in real time.
Exactly. It requires high bandwidth, low latency processing of complex, noisy sensor data about human state, which is where that kind of hardware shines.
Okay, this has been a fascinating journey. We started with the basic architecture, the why of brittleness and ethics, looked at applications, tackled accountability, and now landed on the AI actually managing the human input for efficiency and reliability.
It really covers the full spectrum. So to quickly summarize the key takeaways for everyone listening first. Systemic resilience. HITL isn't a bug, it's a feature. It provides that essential human judgment context, ethics, adaptability needed to turn brittle AI into robust, resilient, socio-technical systems that can actually function reliably in the messy real world.
Got it. Resilience through human judgment. Second takeaway.
Strategic deployment. The future isn't about drowning humans in endless review tasks. It's about optimized HITL, using techniques like active learning and creating artificial experts to focus that finite, expensive human attention precisely where it adds the most value on the most complex, ambiguous, or error-prone cases. Efficiency is key.
Right. Smart deployment, not brute force. And the third point.
Third, redefine purpose. Integrating AI this way fundamentally changes the nature of human work. AI's greatest potential isn't just automation, it's augmentation. It's liberating the human mind from cognitive overload, from repetitive drudgery. This allows us humans to focus exclusively on what we do best. Nuance, complex problem-solving, ethical deliberation, creativity, strategic thinking. The human becomes the ultimate quality controller, the arbiter of value.
Liberating us for higher-level tasks. That links perfectly to a final thought. The source material suggests the ultimate purpose here is maximizing human flourishing. If prescriptive HITL involves AI learning patterns to optimize the deployment of human expertise and manage our cognitive limits, well, it makes you wonder, should the next pattern we intentionally teach AI to recognize be the patterns that lead to elevating our own collective moral and ethical capacity, ensuring our wisdom keeps pace with our rapidly growing technological power?
That's a profound question. Using AI not just to manage our weaknesses, but to actively help us cultivate our strengths, including our ethical reasoning.
Something to definitely ponder long after this deep dive ends.
Indeed. A lot to think about there.
Well, thank you for guiding us through that complex landscape. And thank you all for joining us on The Deep Dive. I'll see you next time.
Searching for answers to unanswered questions.
This is DigitView.